Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. Today's question comes in from listener Kate.
I'm a first-year student at Medical University and studying parasitology, and my question is, how do parasites understand that they have fallen into a host and that they reach their final or intermediate host?
Thanks, Kate. Parasites are organisms that live in or on other organisms. These freeloaders are dependent on their hosts for their survival, causing harm to benefit themselves and offering nothing in return. That's why they have to come up with all sorts of tricks to evade the immune systems of their hosts, developed over generations of coevolution. You're right to point out, Kate, that often they can go on some extremely complicated journeys to reach what's known as their primary or definitive hosts, where they will become adults and reproduce. Here to tell us more about some of them is Professor of Parasitology at the University of Cambridge, Catherine Merrick.
Thanks, James. There are at least two primary sets of cues that parasites rely on to know that they're in the right place. The first of those is the general environment, factors like temperature and pH and so on. For example, many food and waterborne parasites have a resistant cyst form that survives in the soil or the water for weeks or months, shielding them from damage. And those cysts only emerge and replicate when they get chemical signals from the host's gut, like the low pH of stomach acid or bile salts in the small intestine, which prompt the parasite to activate. Now, notable examples of this include Cryptosporidium, which caused that major diarrheal disease outbreak in Devon just this summer, and Toxoplasma, one of our most common parasites, which is spread through cysts that are found in cat feces. So that's gut-dwelling parasites, but another common signal is temperature. For example, the reproductive cells of malaria parasites only transform and mate very rapidly when the temperature drops from the human body's typical 37 degrees to the 20 degrees or so that tells them they're inside their definitive host, the mosquito.
This is what we're competing with in the biological arms race against malaria. Research has also shown that malaria parasites will sync up with our own body clocks to help their development, another part of their ingenious life cycle. But what about the second set of cues parasites use? Catherine?
The second set of cues are more specific interactions with the host itself. Toxoplasma, which I mentioned earlier, is also interesting here. It will emerge from its cysts in the gut of any warm-blooded animal, but if it detects that it's inside a cat, it reacts differently. In the cat's gut, the parasite undergoes sexual reproduction and produces new cysts, which are then excreted in the feces and can infect others. In other hosts, such as mice or humans, Toxoplasma burrows through the gut wall and remains dormant in the body tissues until a cat consumes that intermediate host, like the mouse. Now, the exact mechanism that enables the parasite to distinguish the cat's gut from any other gut is still unknown, but we do see a similar choosiness in many parasites, including malaria parasites, where we know a bit more. Many host species can get malaria, lizards, mice, humans, but the parasites of mice can't invade human blood cells and vice versa. That specificity is due to the interaction between proteins on the surface of the red blood cells and those of the parasite. Without the precise match, the parasite can't invade. And those specific interactions are of great interest, of course, particularly as potential targets for vaccines.
Indeed, the World Health Organization recently approved a new malaria vaccine that works by injecting malaria proteins into the bloodstream along with an adjuvant to kickstart the body's immune system. This process leads the body to develop antibodies so it's ready for next time it comes across this specific protein related to the malaria parasite. Thanks so much to Catherine Merrick, Professor of Parasitology at the University of Cambridge, for helping with that one. Next time, we'll be answering this question from David. When we look at pictures of the night sky, we see plenty of galaxies as well as stars. How long does it take to create a galaxy? Fantastic question, David. I'm very much looking forward to doing a bit of stargazing for you for that one. Remember to have your say on this and all of our questions on the forum. Log on to nakedscientists.com/forum. And be sure to drop us a line if you have a question of your own. It's chris@thenakedscientists.com. Until next time, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.